and I'm gonna say it again. You gotta practice. You gotta practice. You're not gonna come in on a test or quiz and just ace it if you don't practice. You're gonna have a hard time. You're gonna run into issues. You will probably realize, you will have a sense I did something wrong, but you're not gonna know what it is. Okay, so you want to make sure you stay on top of that. And that's why I made this booklet, right? Like it's everything basically is in here. Some things are in the workbook that I gave you, but most of it I incorporated in here. And I try to post the keys as soon as I can. If I don't ever post something, send me a message. It's like, Mr. Dirksen, where's the key? Please, right? Just be nice about it, right? And sometimes I can do it from home. Sometimes I have to wait until I get here, right? So yesterday we started, right? The three inequalities are right next to each other. The biggest pain for you is going to be something like this, right? You have x and y and x like this, no constant, right? You might want to write that down. No constant, right? Goes through origin. So you got to treat it a little bit. It's a special case, right? Because it goes through the origin. So x and y intercepts are both going to be 0, 0. It doesn't help you. You need a second point. Right? So what we do is we rearrange it. Notice what I did here. I just took that one straight down, and I divided both of them by 4. And so that's my rearranged. I right away told myself where, if it's a dashed, where the true region is, where to shade, right? And then I did this extra step, which I don't have to do with the other type. I let x be something. It could be whatever you want. I would say be smart about it. I chose for it to be 4 because then I know that it would cancel out here just like it did there. So I end up with a nice whole number, right? Even though you could pick whatever. You could have made this 6 or whatever you want, 7. You name it, times 8. You could have gone times 8 if you wanted to. That 3 times 8 is 24. Divided by 4 is 6, right? That would have worked as well. But be smart about it. Anyway, so there's my second point. This is very important, right? So that's why I'm going to do this, because when you come across this, I don't want you to get stuck. Okay. So you need to have a special step at the end. Okay. This one you should recognize right away. This is a special case. Only one variable. Okay. So if it's just y or just x, those are easy. Those are really easy, except for if you mix them up, which some of you did on the AC. You graphed your x horizontally as opposed to vertically. So you need to make sure you have that on your study sheet. But this one goes through, right? I just know that it's solid. The true region, where is that going to be? If it's x is greater than, it's going to be to the right. Okay? And therefore, I will shade left. I will do the exact opposite of what it is. So there's no intercept needed, nothing like that. It's boom, you're done. And that's quite often you're going to have one of those at least. But at first it may not look like it. There might be some excess on both sides, so you're going to have to clean that up. But I don't want to overdo it right now. Can I also mention this here? I used everything except for blue, right? I'm just going to make an arrow, right? I flip. I make sure that stands out. And that's basically because of this. Okay? You divide by negative. And so you tell yourself, watch out for that, right? When that happens, it doesn't always happen. But if y is negative, you have to divide by negative. to get it positive, you need to flip that inequality. All right, ready to graph now, finally. Right? So we did a lot of work. And so you know where this is going. You know me enough that this is word problems, right? Okay, let's graph it. So I'm going to go up here, and I want you to make sure you label the axis, even though right now it's just x and y. Assume that's not going to be the case. So the first one is -4, 1, 2, 3, 4, 0, 3. So make sure you copy this, right? You have one good example, and it's a dashed line. Yeah, make sure you use rulers, especially on my ACs or quizzes, tests. There's not a lot of things that make me upset, but that'd be one of them, right? So make sure you don't get that wrong. Okay, don't be on my wrong side. If you forget, come and see me. I have a couple extras. So there's my first line. I don't shade until the end. I don't. But I do graph it and label it right away. And I actually violated the rule that I recommended you. Graph it on your calculator first. You need to do it anyways for the POIs. You might as well do it right off the bat. So let me get this straight here. I'm going to clear everything. And I'm going to do the first one. 3/4 x plus 3. And then I'll do that other one here, this one. I always do brackets for the slope, just to make sure. And there's a plus 0, but we don't add that, right? And then there's a vertical line. I actually should have mentioned it here. It's a vertical. Right? Think about it. You need to think about the boundary line x is equal to 4. Think about it that way. X is equal to -4, sorry. So no matter what happens, x is always -4, right? So you got to go to -4. No matter what happens, x is always going to be -4. Think of it that way if you forget, right? Anyway, so a vertical line, you go 999, 999, 999. So 9 nines, right? And then I'm going to go x, but I got to do the opposite. If it's -4, I got to plug in +4. Okay, that's a story for another day. Why? As to why, that's beside the point. So I'm going to see if it fits on my standard window, and it does. I have a standard window, zoom 6, right? Zoom 6 is the standard zoom, and that would be a -1010 scenario, right? You're going 10 either way, so that works. It's going to work just fine, and that's what I'm expecting my graph to look like. Do you need that in your notes? I don't know. I will say this: y3 is equal to x plus 4 to graph vertical. Vertical. Okay. And I will make sure you see that this is positive, right? Okay, so let's go ahead and graph that. The next line, I picked 4, -3, so it goes to the origin for sure, and then it's 4, -3, it goes right there. And it's also a dashed line, right? I told myself that. So okay, so just extend it across the whole grid, and then label it for y is less than -3x. You can choose either one, the rewritten version or the original. It doesn't matter. And then I have my -4 line right here. And you know that it's supposed, there's already, it's one of the lines is going through -4 as well. See that? So it just happens to be the case. I'm going to make sure I get this right. Okay, so that's my x is greater than or equal to -4 line. And now this is the very important step that I always make you do, where to shade is where this is where that comes in, right? You know you've established that already. So the first line, this one, I shade below, right? So you go ahead and do that. So you're basically saying all of this is false for this line, for this inequality. So it can't be used, right? It can't be used anymore. Any points in there are gone. And then the other line you shade above the diagonal. So we take that other one here, line it up, and you shade above. All those points are out now. We can't use it because we're looking for the area that would be true for all of them. So you're saying, that can't be it. And then this one, we're going to shade to the left, right? Shade left for the vertical. If you would have shaded the right, which could have been, guys, please don't make the assumption that you're always going to have a nice triangle in the middle. We could have ended up shading the right side if the sign had been different. So our solution region would have been over here, right? So don't think it's always going to look the same. But I have to go shade left, right? Did I say right? Anyways, it's supposed to be left according to what we have up there. So it's a very small solution region, but we still write it in there. We have to. That's very important to me because that makes sure that if somebody were to look at it, it's like, oh, where's your true region? Well, you've identified it, right? We've used reverse shading to make it easier, but that is ultimately what we're after. You want to make a note, right? We use reverse shading for systems, especially for systems, okay? Because imagine you're reviewing, right? It's like, what? How did this happen? Like, why are we shading? The true is above here. Why are we shading below? It's like, oh, because you're using reverse shading. Now let's find the POIs. And this is what you would have practiced at the very beginning when I gave you that handout. So I just do it all in one shot. So notice that my triangle is very small here. It's very, very small. So if you like to zoom in, let me try it. Zoom in. And I'm going to zoom into like that section right there. Let's see if it works. It works pretty good. Except for it doesn't show me this vertical line here. Or is that it? Okay, hold on. Second trace 5 for intersect. I'm on the vertical line and I want to come closer to, so I'm going right. Oh, wait. Okay. Houston, we have, let me see, I'm not seeing the x-axis. Hold on, +5. I'm going to change the x max to 5. So maybe be careful with and I'm not seeing Let's pause the recording here. I feel like I messed up on some. It's all fixed now. So let's find the intersection. So I'm going to go second trace 5. I'm on the blue line, enter, and it jumps to the red line because it's my second equation, enter, enter. So that's negative 2, 1.5. So all you need to do here is write them down. That's one of them. And then I'm going to go second trace 5. I'm on the blue line, so I'm going to hit enter. And notice that it jumps to the second one. I'm going to jump one more up, arrow up or down until you cycle to that vertical line. So I'm going to hit enter, enter, and there it is, negative 4, 0, which we already knew was going to be one of them. And then second trace 5. I'm going to jump to the red line because that's, I want to find the intersection between the red and the black line. So enter, it jumps to the black line, enter, enter, and that is negative 4, 3. Okay. So you want to jump between the two lines that you're interested in finding the intersection for. So I'm using up and down arrows to jump lines. Okay, so we're going to go second trace 5. That's what we use, right? Use up or down to jump lines. Okay, use up and down arrows to jump lines. And again, you're gonna have to practice this. It's not just gonna, you're not gonna naturally just be able to do this. You're gonna have to practice. Okay, now I'm asking you, is negative 3, 1 a solution to the system? Negative 3 would be 1, 2, 3, and 1 would be right there. It looks like it could, but even if it's on this dashed line, it wouldn't be, right? So let's check. So we're going to check that. 3 times negative 3 is less than 4 times 1 minus 12. What are you doing, Mr. Dirksen? I'm using the one way up there, the original first inequality. So this is negative 9 less than 4 minus 12 is negative 8. And is this true? Is this statement true? It is true. Negative 9 is smaller, so true. Keep checking. Okay. 4y is supposed to be less than negative 3x, and x is negative 3 here. So 4 is supposed to be less than negative 3 times negative 3 is positive 9, correct? This statement is also true, so you got to keep checking. The last one says that x is greater than or equal to negative 4, and in this case, x is negative 3. Is this statement true? Is this greater than? It's greater than negative 4, so yeah, it's true. It could have been negative 4 as well. That would have made it true as well, but this is also true. Therefore, negative 3, 1 is a solution. So if you're not, like, you need to plug this in, especially if it's worth marks. Don't just say, yeah, it looks like it kind of does, right? Make sure you plug it in and check for all of them to be true. If you happen to pick the one, let's say the first one would have been false, don't bother with the rest. Just stop right there and say, hey, no, not a solution, because it needs to be true for all of them. Okay. All right. So this is kind of getting you ready for word problems. We're going to have 2 to 3 inequalities for word problems, and I'll guide you through that. So this week we just focused on like non-contextual examples. What is that, right? No word problems attached to them. So I'm going to ask you to try this one on your own. I'm actually gonna tell you that I want you to practice. This is gonna be your homework. This is it. 36 and 37. 36 and 37. And do you notice? One second. And if you, just to make sure, you notice down here, it says the POIs. Just don't look at it just yet. But you got to turn your page later and you're going to find the POIs there. I'm just going to warn you. You ready? You're not always going to have a nice little triangle with the corner points around it. As I said, you could have shaded this whole thing to the right of the vertical, which would have meant that this area here would have been your solution region. In which case, you ready? How many corner points would you have had if this is your solution region? The answer is only these two would have been it. Only these two, right? It's only where the boundary lines connect. So don't always think it's 3, it's 3, it's 3. It's not always 3, okay? So watch carefully what the situation is telling you, okay? And I will post the key to this and to the other one shortly. Let me just see if there's more. No, and then we're starting word problems next week. So it's perfect ending to this week where we just focused on systems without word problems, all right?